give me the differential of this function. So first thing you do is you say df with respect to x, and you take its derivative. Now it's a function of x, so it's easy derivative. 5 times 3 is 15, x squared, and then the derivative of this is 0, so it's 15x squared. Now I told you could treat this as a fraction, so I can multiply both sides by dx, and what I'll get is df is equal to 15x squared, move the dx over, times dx. If you want, you can put this in parentheses, and this is the differential. What does it mean? Of course, a monkey can just do it, but what does it mean? What it's telling you is the differential is basically how much does the function change in the y direction wherever I look on the function. Near the origin, if I put x is equal to 0, what's it going to look like? Well, if I put x is equal to 0 here, then I'm going to get a 0 for the slope, because remember, this term is the slope. And you multiply by dx, and that produces how much the function changes in the vertical direction. But at the origin, the slope is 0, same as it was before. So any change along dx there is going to produce no change at all vertically in the function. Now this is a different function, but it'll be similar to this. And you know that these cubic functions go through the origin like this, and so they have a very temporary slope of 0 right there at the origin. And so it's not going to produce any change in the vertical direction of the function at all at the origin. But if you put something bigger, like x is equal to 1,000 in here, then this slope is going to be much bigger. And so a tiny change along the x direction multiplied through will give you a much bigger response, because you know, even though I told you that you wouldn't know for this example, but you know that cubic functions, they go up through the origin, and then they get very, very steep again there. So they have a very large slope when you get to very big negative and positive values of x. If I put a very large negative value in here, like negative 100, I'm going to square it, and I'm going to get a positive number, a positive big number. And when I run it through, multiply that big positive number times a tiny differential in the x direction, I'm going to get a very large response out. Learn anything at mathandscience.com.